So the New South Wales Government is committed to reducing plastic pollution. We are in a bit of a plastics crisis at the moment. We produce about 800,000 tonnes of plastic waste each year. Microplastics are a particular insidious problem. They're really hard to get out of the environment. We find them everywhere. They're in all corners of the world. They're in our bloodstream. They're in the food that we eat.
In 2022, we undertook a marine debris threat and risk assessment, which identified microplastics as a priority threat in our waterways and in our coastal waters. The marine debris threat and risk assessment identified a huge knowledge gap surrounding the distribution and abundance of microplastics in New South Wales. So today we are here on the Parramatta River and we are surveying the river for microplastics.
Yeah, so we're developing a deeper understanding of the microplastics by doing a broad-scale statewide assessment where we go to 120 waterways and assess the microplastic density in those waterways. So in order to assess the microplastic contamination levels in each of the waterways, we have purposely built a net, which if you think about a manta ray or a whale shark, how it feeds, the net acts very similar to that, of which it will sit on the top 15 centimetres of the surface of the water. In the 120 waterways that we've assessed, 10% of those estuaries have what we call nurdles. This is also known as plastic feedstock, which is what plastic manufacturers use to develop plastic items. In all of our urban estuaries, we're finding a lot of artificial grass. We're also finding a high percentage of polystyrene.
Yeah, so these samples here are an example of some of the microplastics we're finding in the estuaries, and the research we're doing here is allowing us to understand where they're coming from, which catchments they're coming from, and in some cases which LGAs, and in certain cases which factories. So then we're able to work with our partners in Operation Clean Sweep, to work with councils and industries to really target these items at source and stop them leaking into the environment in the first place.
At the lab, we digest the sample. We then use density separation by floating the microplastics using a supersaturated water. We then dye the microplastics and filter them through a purposely built filtration system. Once we dye the microplastics, we put them into a dark room and we excite the dye of the plastic with a blue light. We're then able to photograph the fluorescence. Once we have photographed the microplastics, we then have a script which automatically counts the number of fluorescents in the photo. This gives us the density of microplastics in each waterway. We will then be further analysing all the microplastic samples using an FTIR, where we can identify each polymer type with the hope of identifying source and also gathering more information so we can not only see where the worst estuaries are in the state, but also what are the most polluting microplastic items. So by the end of next year, we will be able to tell you what the density of microplastic is for the 120 waterways which we've assessed. There will be a grade for that estuary assessed of high, medium or low, and there will be interactive heat maps for the microplastic across the entire state.
So this research is really critical for how we design our programs. So understanding the source and the scale of microplastics helps us then go upstream and target initiatives like Operation Clean Sweep, like the broader litter prevention program. And that knowledge that we have is really powerful to ensure that we're designing our programs in a real targeted way.